my name is Siti Nurshafina binti Rosli. Today I'm gonna explain question 1 with optimal page replacement algorithms. So for the question 1, the question is identify the number of page fault by using the optimal page replacement algorithm. So what is fault? Fault occurs when page is not currently in memory. And also, what is optimal page replacement algorithm? So basically we will replace page that not be used for the longest time in the future. So how to use it? So we will start with 104 in the frames because in the question it is already stated that this one given the previous occurrence of page address stream which produce the entry of the page table shown in table 1. So this is the entry that already provide with the question. Okay, so we'll start with 104. We will start with number 1 or page 1. So we see that number 1 is already in frames. So we just copy the frames with 104 and next is 4. The same thing already have it in the frames, and we continue with 3. So 3 is not in the frames, so now we will use the optimal page replacement algorithm. So we will see from the from the right side. 104 we will compare which one is not will use in the future, like the longest time. So 104 we see 0 have it here, 1 have it here, and 4 is like the fathers. So we will replace it with 4. So it will be 103. Okay, so this will be false because currently 3 is not in the frame. So next we'll continue with 0. So 0 is already in the frame, so we will just copy it, and then 1 also is already in the frame, and next is 2. So 2, there's no 2 in the frame, so we will use the replacement algorithm which is optimal. So we will compare 103. So 1 is in the future and 0 and 3 is no. So we can choose either 1. So I will choose 0 to be replaced with 2. So it will be 1, 2, 3. And next, by the way, this will be false. Okay. And next we continue with 4. So 4 is not in the frame, so we will use the replacement algorithm. So which one we'll use? We have 1, 2, 3. So 1, 2, 3, we have 1 right here and we have 2 right here, and we don't have 3, so we can replace 3 with 4. So it will become 1, 2, 4, and also it will be false. Okay, next we have 2. So 2 is in the frame, just copy it, and then 2 in the frame again, copy it again, and 1 also is in the frame, so copy it. Okay, so that's all. So identify the number of page faults. We have 3. So the total number of page fault is 3. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Alicia Mansur binti Sakra, and I'm going to present to you about LRU page replacement algorithm. The means of LRU is least universally used. So we can see this question. We have five pages and 3 frames. The previous occurrence of the page stream is 303140, and the produce the entry of the page table shown in table 1. So we can see table 1. So the frame number 0 have number 1. So I'm going to write down the number 1 in the frame 0. And the frame number 1 has page number 0. And the last frame number is frame number 2 has number 4. So first number we're going to have 104. And the page address string continues as follow: 14301242221. As you can see here, I already write down our page number address string. So the first page, we have page number 1, and we already have page number 1 in our memory. So we're gonna write back 104, and the number 1 become the most recently used. So the next number is page number 4, and also the same, we already have page number 4 in this memory, so I'm going to write down 104, and number 4 become the most recently used. The next page is page number 3. In our memory, we doesn't have number 3 yet, so we're going to look back which one. So this the least recently used, and as you can see, the less recently used is page number 0. So we're going to replace number 0 with 3. So I'm going to replace page number 0 with 3, and I'm going to write down. So what's going to happen? So next page number is page number 0. And as you can see in our recent memory, in main memory, we doesn't have page number 0. So we need to look back which one the least recently used. As you can see, the number 1, page number 1, the least recently used, and we're going to replace number 1 with 0. So 0, 3, 4. And what's going to happen? The next one, we have page number 1. And page number 1, so we need look back because now page number 1 doesn't have in our memory. So the least recently used is number 4. So we're going to replace number 4 with 1. So replace it and write down there. And what's going to happen? The next one is page number 2. Page number 2 we doesn't have yet, so you're gonna look back which one the most recently used. The least recently used, I'm sorry. And the least recently used is number 3. Number 2. So we're gonna replace number 3 with 2. So we're gonna write down what this number back. So what's gonna happen? So we already have 4, 4. So the next page is page number 4. And we can see we doesn't have number 4 yet. So we're gonna look back which one number the least recently used. And as you can see, number 0 is less recently used. So we're gonna replace number 0, page number 0 with 4. So replace it with 4 and write down back. So what's gonna happen? The next one, we have page number 2. As you can see, page number 2 I already have in this memory. So I'm gonna just write down there. So number 2 gonna become the most recently used. We look the next one. We have page number 2 again. So we already have page number 2 in our memory. So we're gonna write back for 1 and not what's gonna happen. And we look the last one. The last one we have page number 1. And you can see in our memory we already have number 1. So no what's gonna happen. So we just gonna write down all this back. So we already finished our things. Okay. As you can see, we have 1, 2, 3, 1, 2, 3, 4, 5. We have 5, 4. So the total number 4. Number of 4 is 5. So this and my present. Thank you.